going over the review of the problem assignment, problem 15.8 and 15.9. As you begin to lay this out, remember when you draw it, this is the north arrow, which will become vertical in your CAD screen. Okay? So when you lay out these lines, you will need to lay them out using the bearings that's indicated here. So this will be oriented nearly vertical. Okay? When you compare the two drawings, there's a discrepancy between this distance and the distance on the other plot plan. So you use the smaller distance, should work. Also, the degree measurement, the bearing, would be more accurate on the other sheet on 15-9. So you use that. When you lay out these bearing lines on your CAD screen, use the south 41 degrees, 15 minutes, 57 seconds. When you're using that and you're entering that, you will use the surveyor's units. So you will enter south. Well, that's not a good example because you're going to have to figure out what bearing this is. So we'll use this one over here. South 43 degrees, 33 minutes, 49 seconds west. So when you enter that into AutoCAD, you'll enter S 43D, that's lowercase d, 33 apostrophe, 49 quote mark, W. So your entry will be @ the distance it is 187.57, and then your angle sign, your less than symbol, then S, a capital S, 43 degrees, 33 apostrophe for minutes, 49 seconds, quote mark for seconds, and then a capital W, indicating that it's moving into the south quadrant. Also, remember that you have to lay out this outline of the building and the retaining walls, and there aren't any measurements to go by. So you'll need to use a small piece of paper and set it to 10 foot, and then make some subdivisions on here for that. Divide up the 10 foot, so that would become 5 feet, and then divide it again, that's 2.5 feet. Then you can use that to measure with and measure the building to lay it out in CAD. To find out where to start it, you would measure from this corner after you got the property laid out. Then you'll use this paper scale and find out where this corner is. Likewise, this corner, which there is a mistake here between the 73 feet that they're showing, because I can guarantee you that's not 73 feet. Okay, so you'll need to verify that, and it needs to not be to here 73 feet, but to the corner. However, how many feet you can accurately measure to determine where that is. Okay, and then this might be close to 32 feet. It might be pretty accurate, that corner. So yeah, a little fudge work, we call it, a little work on getting it to be accurate based on our sketch and our information that we have to work from. When you finish the drawing, as I said, it'll be north will be facing up, so this property will be turned, okay, so that this bottom property line will be almost horizontal. Not horizontal, but will be at a different angle. And I'll try to turn it on here so you can see what I mean. So your north arrow would be like so. So your property is going to look like this, just like you see it. Okay, it'd be oriented like so. If you have any questions about how to get started, then you need to email me. Remember to set up your sheet as decimal units, and your degrees would be surveyor's units, and you want to set up the precision on the surveyor's units so that seconds are displaying, just plain whole number seconds. So you'll look for that in your display right here, 49, a place that shows that. It'll say 0 and then the quote mark symbol in your display of setting up your units. Let me demonstrate that real quick. So under your units command, you'll set it up as decimal and surveyor's units so that you have at least the whole number for seconds showing, and then 3 place would probably be good for your decimal measurement. Remember, this is decimal number, and we're going to imagine that it's feet. Okay, do not set it up to be in engineering units. Okay, that's feet and decimal inches, which is not how we draw that on our plot plan. That's not the correct units. So we'll use decimal, and then any measurements we make, or we have to of course show the length measurement on the sheet, we will either measure it beforehand and type in the foot mark, or we can set up a dimension style that will automatically place the foot mark for us. When you type in that length, the various lengths, you would need to do it so that you're going to use no kind of snaps. You can turn off everything down here, and all you're doing is entering the old-fashioned relative polar. So I'll try to type in the first one. You can see it's displaying down here in the command line. So 187.57, no foot mark, okay, is indicated, no foot mark. Then the less than symbol, the angle symbol for your angle, and then south 43 degrees, 33 minutes, that's the apostrophe sign, 49 seconds, that's the quote mark. And then which way is it, what quadrant, and it's west, the west quadrant. It's either going to be a W or a E there. Okay, you press enter. Of course, it's going off my sheet because I have not set my limits up. And so I'll do a zoom extents. And so there's my bearing line for my first piece of property, with north going in the Y direction, okay? And then your east is in the X direction. So just draw each line with its own length and bearing, and I would draw them just out in space somewhere. Don't worry about connecting them, and then move them, connect them endpoint to endpoint, and see if they all connect nicely. And you'll have to make a decision on some of it, whether or not where there's a gap, you'll have to decide which one is more accurate. Alright, so I wanted to give you that little bit of help, a little instruction on getting the problem going. And as I said, email me or stop by and see me if you have any questions about getting going on this problem.